In section 22, we will classify and describe the graphs of polynomial functions. Examining number 1, we're going to look at the degree, the zeros, the behavior, the number of relative maximums and minimums, and then the end behavior. So when we look at the degree here, we're going to look at this is x the first, so we've got a first degree, this is going to give me the second degree, and then this accounts for 2 more, so our degree on this one is going to be 4. As far as the number of zeros, when we set this equal to 0, we're going to get 1. When we set this one equal to 0, we're going to get -2, and then the last one gives us +4, which is a double root. So I get 3 different locations, one of which is a double zero. As far as the behavior, I know that this one, because it's got a positive lead coefficient, I know it's going to end going up. So working backwards here, the last one's going to be increasing. And then I need a total of 4 behaviors because it's a 4th degree. So if the last one is up, the one before that is down, the one before that is up, and the first one should be down. So it's decreasing, increasing, decreasing, increasing. As far as the number of relative maximums, well, if I look at what I just got here, if I think about how that would look, it would go down, which is going to give me a minimum point. Then it would go up. Then it switches to down, so I just got a maximum point. So I've got 1 maximum. And then if I go down and then back up, that gave me 1 maximum and 2 minimum values. And as far as the end behavior, we know that since this is positive, our right side is going to approach positive infinity, and because the degree is even, they're going to have the same behavior, so they're both going to be positives. For model 2, we do the same thing. We look at the degree, so here is going to be 1, 2, 3, 4, 5. This is a 5th degree. As far as our zeros, with this -2 right here, I don't need to set that equal to 0. Even if I did, I wouldn't have anything to solve for, so this isn't going to give me any zeros. This right here is going to give me a -4. This is going to give me 6, which is a double root. This is going to give me -5, and then this one gives me -11. So I have a total of 4 locations there, one being a double zero. As far as our behavior, again for this one, since we have a negative here, it's going to end down. And because it's a degree of 5, it's going to have a total of 5 behaviors. So working backwards towards the beginning is going to make it decrease, then increase, then decrease, then increase, then decrease. As far as the number of relative maximas, if I go down and then up here, that's going to be 1 minimum. Here's up and then down, so I have a maximum. Down and up, that's a second minimum. Up and down, that's a second maximum. So I actually will have 2 of each in this situation. And we do want to make sure that these combined would give me 1 less than the total degree right now. As far as our end behavior, the negative here tells me the behavior on the right side. So this is going to approach negative infinity here. And because we were working with an odd degree here, these are going to be opposites of each other. So we have a positive infinity on the left and a negative infinity on the right. For this example, our degree is going to be, we've got to the first power, we have 2 more here, so our degree is 3. As I factor this, I end up getting my zeros at 2, 4, and -2, and those can go in any order. And then as far as our behavior, because we have this positive lead coefficient, it's going to end up. And if I go back from there, the one before that would be down, and then my first one is going to be up. So increasing, decreasing, increasing. For the number of relative maximums, if I think this is increasing, then decreasing, that's 1 maximum. Then if it decreases, then increases, that's going to give me 1 minimum. So I actually get 1 of each here. And again, these 2 should combine to give me 1 less than the total amount that I have for the degree. As far as our end behavior, because it's positive lead, we know that this side is going to be positive. And then on this side, it's going to be the opposite of that because it's an odd degree. For number 4, here our degree is going to be 3. As far as the number of zeros here, we're not actually going to factor this out. What we're going to do is we're going to kind of assume that we're going to have 3 total zeros because our degree is 3. Our behavior here, we know that the last one is going to increase because this is positive. So if I work backwards from there, I get increase, decrease, increase. The number of relative maximums, if I increase, then decrease, that's 1 maximum. And if I decrease and then increase, that is going to give me 1 of the low points. Then finally, it's a positive lead. So this side's going to be positive. It's an odd degree. So they're going to be opposites of each other. For model 5, here the degree is going to be 4. For the number of zeros, we're expecting 4 of them. The behavior, it's going to end down, and then I want to work backwards towards the beginning. So it's going to end up being increase, decrease, increase, decrease. For our number of relative maximum, well, if I increase and then decrease, that gives me a maximum. Then if I decrease and then increase, that's one minimum. If I increase and then decrease, that's another maximum. So I'm going to get 2 max points and 1 minimum point. Finally here, if this is negative, that means my right side is going to be negative. Then the fact that this is an even degree means that these two are going to be exactly the same. So they're both going to be negative infinity. For number 6, here the degree is going to be 2. I'm expecting 2 zeros then. For the behavior, the second behavior is going to be increase, so the behavior before that is decrease. As far as our relative maximums and minimums, as far as our relative max and min, this decreases and then increases. So we have a low point in this one, no high points in this one. And then for our end behavior, because it has a positive lead coefficient, this one's positive infinity. And then because it's an even degree, they're going to be the same. Now if we take a look at this graph, the degree of this graph, well, we see that it passes through 1, 2, 3 times. So we're expecting that this is a degree of 3. We also see that there are 3 zeros. As far as the behavior, again, if I start on this side and I trace the graph, it goes down, then it goes up, then it goes down. So this is decrease, increase, decrease. The number of relative maximums is going to be 1 because I have this 1 point right there, which is a high point. And then for minimums, it's going to be 1 because I have 1 low point. For the end behavior, if we put arrows on this, that's how we can kind of tell. On the left side here, it's pointing up, so that one's going to positive infinity, and on the right side, it's pointing down, so that one's going to negative infinity. And again, those should be opposites of each other since this is an odd degree. For this one, our degree is going to be, we're thinking this counts for 2, so 1, 2, 3, 4, degree is 4. Number of zeros, we've got 3, but one of them is a double root. For the behavior, it's going to go increase, decrease, increase, decrease. Maximum points are going to be here and here, so I have 2 of them. The minimum points is down here, so that's 1 of them. And then as far as our end behavior on the left side, if I were to put an arrow here, this is pointing down, so that's going to go towards negative infinity. The degree is even, so even without looking at the graph, we know that these should be the same, but then we can see that this is pointing down as well, so they both approach negative infinity. For number 9, here when I'm looking at the degree, I've got 1, 2, 3, 4, 5 times that it passes through the x-axis, so I'm expecting the degree to be 5. The number of zeros then is also 5. For the behavior, it goes increase, decrease, increase, decrease, increase. Relative maximas are going to be here and here, so I have 2 of them. Relative minimums I have here and here, so there are also 2 of those. And then as far as our end behavior on the left side, if I put an arrow here, that's pointing down, so negative infinity. And on the right side, this is pointing up, so that would be positive infinity. Again, we know that because this was an odd degree, these should have been opposite of each other. For 10, when I'm looking at the degree, this is 1. This one counts for 2, so I'm at 2, 3, this is 4, and then this one also counts for 2, that's 5, 6, so it's a 6 degree. I do want to make sure, because this gave me an even, that these should be extending in the same direction, and they are. For the number of zeros here, I have 1, 2, 3, 4 locations, but 2 of them are double zeros. For our behavior, again, if I start here, it goes down and then up and then down, up, down, up. So my behavior is decrease, increase, decrease, increase, decrease, increase. For relative maximas, I've got a point right here and a point right here, so I've got 2 of those. For the minimums, I've got this one, and this one. So there's 3 of those. Again, we want to make sure that these add up, their total adds up to give us 1 less than the degree. And then as far as our end behavior, if I were to put arrows on both of these, they're both pointing up towards positive infinity. So now we're going to look at each of these and we're going to classify them by their degree and their number of terms. So for number 11, the degree is going to be 2, and we call that quadratic. And then because there's 2 different terms here, it's a binomial. For number 12, this is a 4th degree, so we're going to call that quartic. So this is a quartic function with 1, 2, 3, 4, 5 terms. For 13, this is a fourth degree. So again, this is a quartic function. And since there are three terms, we call that a trinomial. So quartic trinomial function. For number 14, this has a degree of 1, which we call linear. And then we only have one term, which is called a monomial. So a linear monomial function. For 15, the degree here is 3, so that's cubic. And then we have three terms, so that is going to be a trinomial. And then for 16, the degree is 2, we call that quadratic, and then there's two terms, which makes it a quadratic binomial function. We'll do the same thing with 17 through 22. So here, degree is 5. We don't have a specific name for that. We just call it fifth degree. And there are 1, 2, 3, 4, 5, 6 terms. So this is a fifth degree polynomial function with 6 terms. Here, this is a fourth degree, which we call quartic. And then there's 1, 2, 3, 4 terms. So quartic function with 4 terms. For number 19, it's a fifth degree, which doesn't have a special name. And then there's only one term, and that's called a monomial. So this is a fifth degree monomial function. For number 20, here, third degree, that makes this one cubic. 2 terms is binomial, so we call it a cubic binomial function. For 21, the degree is 2, so that's quadratic. And then from there are 3 different terms, which is a trinomial. So this is a quadratic trinomial function. And then for 22, the degree is 2, so this is quadratic. And then there's 2 terms, which makes it a binomial. So it's a quadratic binomial function. Do the same thing for 23 through 28. For 23, the degree is 1, which we call linear. And then there's 2 terms, and that's called a binomial. So this is a linear binomial function. For 24, the degree is 4. So that's quartic. And then there's 3 terms, which we call a trinomial. For 25, degree is 3, so that's cubic. There's 4 terms, so it's a cubic function with 4 terms. For 26, this doesn't have any variables in it, so it's called a constant. And there's only one term, so it's called a monomial. So this is a constant monomial function. Here the degree is 2, which makes it quadratic. There's 3 terms, which makes it a trinomial, so we call that a quadratic trinomial function. And then for 28, degree is 5, and there are 1, 2, 3, 4 terms, so this is a fifth degree polynomial with 4 terms.